SAMS, the Sediment Acoustic-speed measurement system. A sediment-penetrating probe, tipped with a hydrophone and an arm with 10 acoustic sources. This source-receiver arrangement crisscrosses the sediment volume to measure sound speed and attenuation as functions of depth and frequency. SAMS components were moved from storage in labs and packed in shipping containers to travel from Seattle, Washington to Woods Hole, Massachusetts. Assembly there required 3 engineers nearly 4 days. First task, set up the tower, central carriage, and receiver probe. Then assemble the recording system, water pump, and hydrophones. With all connectors cleaned, central carriage sanded smooth, and cables wrapped, it was time for tests of the source receiver system. Many cables connect SAMS from the ocean bottom to the ship: power, streaming video, control, and data cables. During the Office of Naval Research Seabed Characterization Experiment at the Great Mud Patch on the continental shelf south of Martha's Vineyard, SAMS had to operate at depths greater than ever before. Shipboard compressed air and water jet drilling systems were not feasible at 80 meters. So engineers designed a new drilling system, a two-way pump that creates a jet or suction force to mount to the tower itself. SAMS completed 18 stations during the early 2017 experiment. The trip from the ship's fantail to the bottom takes 20 to 30 minutes, with the cable bundle married to the ship's trawl wire every several feet. At each target site, sound speed and attenuation were measured in the superficial mud layers of varying thickness. The SAMS stations were chosen to coincide with coring activities by other researchers for comparison purposes. SAMS measurements show that mud has a sound speed lower than water, with little variance across its volume and little frequency dependence.
Okay.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.